Hello, this is part three of Riemann Sum. So we're going to continue questions four through I think seven. Yeah, we're going to finish off with the Riemann Sum. So let's go start. Let's start with question four. So question four says, excuse me. Question four says y equals square root of 1 plus x on the intervals -1 to 9. Let the intervals be divided into five equal subintervals. Find the values of the Riemann sum using left endpoints, right endpoints, midpoint, and trapezoid method. Okay, so what I would do first? I would first graph y equals square root of 1 plus x. So that's y equals square root of 1 plus x is also the same thing as square root of x plus 1. This x plus 1 means a horizontal shift of 1 unit to the left. So it might look something like this. Okay, so here's -1. And then this is this. And we gotta, and let's pretend 9 is like right here. And we gotta find the area between -1 to 9 using right, left, midpoint, and trapezoid, right? So let's start with the left. Okay, so if you kind of, here, let me draw it on the left. We kind of draw the box, or let's make it more detailed. Here's your x, here's a y, here's -1, going from 1 to 9. I mean, -1 to 9. Here's 1, 2. So if you go from, just visually try to make rectangles like from -1 to 1, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6 to 7, 7, 7 to 8, 8 to 9. So yeah, let's make our box thing. Okay, I'm going to draw my, boxes. Okay, so from now we're doing left hand, so we're going to take this side. Oops, here, let me use another color. Let's use this color, Galaxy. So yeah, we're gonna the height will be on this side. And so from -1 to 1, what is my delta x? It is 2, right? So this is a distance of 2. This is also distance of 2. 3 to 5 is 2. Looks like they're constant, right? So they have an even height. That's good because now that means we could factor out a 2. So we could take out, so on part A, we're doing left. And we're going to take out a 2. And then let's do f of, so we're doing left side, so we got to find f of -1 plus f of +1. So we got to do this side. That would be our height. And then the next one would be f of 3. And then the next one would be f of 5. And then the next one would be f of 7. Okay. And then because we have a function already, our function is y equals square root of 1 plus x. We're just going to plug in these values here. So y is like our f, right? So if I plug in f of -1, what would that be? That is square root of 1 plus -1 is square root of 0, which is 0. If I plug in +1, that'd be 1 plus 1, which is square root of 2. If I plug in f of 3, 1 plus 3, which is square root of 4, which is 2. And then if I plug in f of 5, which is square root of 6. And then if I do f of 7, it's square root of 8. So all we got to do is plug in these values. So f of -1 is 0, plus f of 1 is radical 2, f of 3 is 2, f of 5 is radical 6, and f of 7 is radical 8. Okay, and when you put it all together in the calculator, you should get about 17.384. Yeah, so that was the answer for part A. Now we have to do the right side. Okay, so we're doing part B, right. So draw your rectangles again. Okay, so we know that the delta x is a constant of 2, right? This is 2, 2, 2. Okay, what else do we know? So now we're going to do the right-hand side. So let's use another color. So we're going to do f of 1, f of 3, f of 5, f of 7, f of 9. Okay, so as you can see, the width is a constant of 2, or the delta x is 2. And then, so it's good, you could just factor out that 2. And then we got to find f of 1 plus f of 3, f of 5, f of 7. So now we could just put it back into our function. So our function is f of square root of 1 plus x. So if I plug in f of 1, it's radical 2. And then if I do f of 3, it's square root of 4, and that's 2. And then f of 7, square root of 8. And then 9, just square root of 10. Okay, and then so now what we're going to do is plug it in. So f of 1 is radical 2, f of 3 is 2, f of 5 is radical 6, f of 7 is radical 8, and then f of 9 is radical 10. Uh, and then if you put that in the calculator, you get 23.79. Okay, so that was that one. That was B. Now let's do midpoint. So midpoint is where you have to find the height of the midpoint. So let me draw the image. Okay. So from what's the halfway point from -1 to 1? It would be 0. And then, wait, let me draw my rectangle. So this is, here's 3, here's 5, here's 7, etc. Let me use a different colors so you don't get confused. Okay, so what I'm doing is finding the midpoint. So what's the midpoint between -1 and 1? 0. And what is the halfway point between 1 and 3? 2. And if you don't know, sometimes it could get confusing. What you do is just take the average between the numbers. So for example, the midpoint between 1 and 3 is you add 1 and 3 and take the average, divide that by 2, and that is how I got 2. Okay, and then what is the halfway point between 3 and 5? 4. Okay, what is the halfway point between 5 and 7? 6. And then what is the halfway point between 7 and 9? 8. Okay, so because our total distance is constant from -1 to 1 is still 2, and then 2 to 3 is 2, right? So your delta x is still 2. So it's going to be 2, and then, so we're doing the midpoint. So we need f of 0. What else? We need f of 2, f of 3, f of 4. Wait, no. F of 2, f of 4, f of 5. No, no, no. So we're going midway. So from -1 to 1, it's f of 0. From 1 to 3, f of 2. From 3 to 4, f of 4. So no f of 3s. And then from 5 to 7, it's f of 6. No f of 5. And then from 7 to 9, it's f of 8. Okay, so that's what we're going to find. So it's going to be f of 0 plus f of 2 plus f of 4 plus f of 6 plus f of 8. And what is our function? Our function is f of x equals square root of 1 plus x. So if you plug in f of 0, 1 plus 0 is square root of 1, which is 1. If you plug in f of 2, 1 plus 2 is square root of 3. If you plug in f of 4, that's 1 plus 4, which is square root of 5. And then if you plug in f of 6, that's 1 plus 6, which is square root of 7. And then if you do f of 8, it would be 1 plus 8, which is square root of 9. And we know that's 3. Okay, put it in the, so it's going to be f of 0 is 1, f of 2 is radical 3, f of 4 is radical 5, f of 6 is radical 7, f of 8 is 3. And when you put it all together, you should get 21.28. Okay. Okay, next is trapezoid. So trapezoid is I'm out of time. Here, let me move it to the right because I am out of space. Okay, so yes, move it to the right. Okay, so I'm going to do D, and we are doing trapezoid. Okay, so how we do the trapezoid method is it is so it looks like so it's going to be 1/2 delta x of f x naught, and so we have remember we're taking so on this trapezoid right here we have to find the height of f of -1 and f of 1, and then yeah, and then f of 1, f of 3, f of 5, f of 7. So the thing is, our delta x is still constant of 2, so you can take out the 2. So it's going to be 1/2 delta x, which is 2, times f of -1. So we got to find this height right here, and then this height. Here, let me use a different color because it. Okay, so we got to find f of -1, f of 1, f of 3, 5, 7, and f of 9. And that because of delta x, the height, the width is still constant 2, you can take it out. So f of 1 plus, so f of -1 plus f of 1 plus, you know what? Yeah, sorry. So f of -1 plus f of 1 plus, so I took out the height, which is 2, and then it would be f of 1 and then f of 3, right? And then it's going to be plus f of 3 and then f of 5 plus f of 5 plus f of 7, and then plus f of 7 and f of 9. Okay. And when you put that in the calculator, so 1/2 times 2 is 1. And then if you plug in f of -1, you should get square root of 0. And then if you plug in f of 1, that would be What is our function? Our function is y equals square root of 1 plus x. And then f of 1 is f square root of 2. F of 1 is also square root of 2. F of 3 is square root of 3 plus 1 is 4, so square root of 4 is 2. F of 3 is also 2 again. F of 5 is 5 plus 1 is 6, so square root of 6. And then f of 6 is also square root of 6. Plus f of 7 is 7 plus 1 is 8, so square root of 8. So that is going to be, when you put it all together, you should get 20.547. Okay, good. Okay, let's move on to question 5. Okay, so question 5 says the function f of x is continuous on the closed intervals from 2 to 9. Find the trapezoidal approximation from 2 to 8 of f of x dx using the table of selected values. So they give us a table, x, and then the f of x is like your y coordinate. So what do you know about this table? It is unequal, right? You went from 2 to 3, that's a distance of 1. From 3 to 6 is a distance of 3. From 6 to 8, a distance of 2. So they're unequal. So if it's unequal, you have to calculate each trapezoid separately. So what that means is we can't remember in the last problem we took out a 2 because their height, their delta x was 2. We can't do that anymore. Okay, so what I'm going to do is kind of draw the image. So we've got to find the area of each trapezoid individually. Okay, so the area of a trapezoid is 1/2 times delta x plus the 2 heights, right? So it's going to be, so let's do the first trapezoid. So we have to do it individually. So it's going to be 1/2, and then the delta x is going to be 1 for this one, right? And then we have to find f of 2 and f of 3. Okay, so that's just one area of the trapezoid. Let me use a different color. So what I mean is you're just finding the area of this trapezoid right here. Now let's do the other one, this one right here. So it's going to be 1/2. What is my delta x from 3 to 6 is, the distance from 3 to 6 is 3. And we got to find f of 3 and f of 6. Okay, and then it's going to be plus 1/2. And then what's the delta x from 6 to 8? 2. and it's going to be from f of 6 to f of 8. Okay, and then just do the algebra. So uh, okay, so they don't give us a function, they actually give us a table, so that's even better. 1/2 times 1 is 1/2. F of 2, you have to look at the table. F of 2 spits out a 3, and then f of 3 spits out a 5. Okay, plus 1/2 times 3, that's 3/2. And then look at the table. F of 3 is spits out 5. F of 6 spits out 7. Plus 1/2 times 2 is 1. And then f of 6 is 7. And then f of 8 is 10. Okay, so this is going to be 1/2. 3 plus 5 is 5, 5, 6, 7, 8. And then 5 plus 7 is 8, 9, 10, 11, 12. Plus 1. And then 7 plus 10 is 17. Okay, and then if you put it all together, you actually get a whole number, which is 39. Okay, the next one is 6. Okay, so on example 6, the velocity graph in feet per second of a braking car is shown in the graph below. Use it to estimate the distance traveled. So they give you this image. So it says use it to estimate the distance traveled. So you can choose midpoint or trapezoid. So yeah, so I'm going to choose, so you can choose midpoint or trapezoid. Why would I use those? Is because it's probably the most accurate, right? So let us do midpoint. Midpoint, the midpoint is you have to find the delta x. So if we're going from the boundaries 0 to 6, this is like your A, this is like your B. So the delta x will be uh, B minus A over 3. So it's B minus A, so that's 6 minus 0 over 3 because it's your halfway point. And that gives you 2. So what we're doing, if you look at our rectangles, here's 0, 1, 2, 3, 4, 5, 6. Okay, so we're going to draw a rectangle here. Okay, so it's going to be, since they both have a, they all from 0 to 1, 1 to 2, 2 to 3, they both have a width of 1, constant 1, right? They're all 1, right? 1 to 2. 2 to 3 is 1, 3 to 4 is 1, 4 to 5 is 1, 5 to 6 is 1. So that means we could factor out a 2. And we're doing midpoint, so you need to find v of 1. And then you need to find v of 3. And then you also need to find v of 5. So v of 1 plus v of 3 plus v of 5. And it's going to be 2. And then kind of have to estimate it. So v of 1, it looks like if you look at your graph, v of 1 looks like it's at 50. V of 3 is going to be about, what do you think, 25? Yeah, I think it's going to be about 25. My graph is not a scale, but it, sh it should be about 25. And then V of 5 is, looks like it's about 9. Yeah, my graph is not a scale. It is 9. And when you put it all together, you should get 168 feet. Okay, now let's do the trapezoid method. In trapezoid method, I think here, let me draw the image. I think the delta x is the same. So we don't have to, we could factor out that too. Okay, so we're going to find this trapezoid, and this trapezoid. And then it's going to be, so the distance from 0 to 2 is 2. The distance from 2 to 4 is 2. And then from 4 to 6 is also 2. So our delta x is a constant too, so we can factor it out. And then we got to find, so if you look at the first trapezoid, we got to find the f of 0 and f of 2. So v of 0 plus v of 2. Plus, and then if you look at the second one, this one right here, you're going to find the height of f of 2 and f of 4. And then if you look at the third trapezoid, you got to find the height of f of 4 and f of 6. Whoops, why did I put an f? It should be these. Okay, and then that's going to give you 1/2 times 2. V of 0 is 70. Yeah, it's about 70. And then V of 2 is what is V of 2? Looks like it's about 35. I just realized something. Because they share both sides, yeah, this is off. Because they share, so like for example, V of 2, this trapezoid 1 shares the side with trapezoid 2. Um, you don't have to do it twice. So you just find v of 2 and then f of 4, and then you don't have to do this 4 because they're sharing a side. And then you do have to find v of 6. So this would be 35, and then what's f of v of 4 is about 9. I mean, not 9, it should be 15. My graph is off. And then what's v of 6? V of 6 should be 0. And when you put it all together, you should get 170 feet. Okay, so 168 and 170 are very close. They were the most accurate, right? Okay, last problem. So example 7 says, let f of x be twice differentiable function. The table below gives the values of f of x at the selected points on the cross-closed intervals from 2 to 13. Okay. It says estimate f prime of 4. So how do we estimate? Well, what is derivative? It's the slope at 4, right? So f prime of 4 is basically finding the slope at 4. So here, I'll show you. So slope is, what is this formula for slope? It's y2 minus y1 over x2 minus x1, right? And what we got to do is find, it's also f of b minus f of a over b minus a. So f prime of 4, if you estimate it, is basically f of 5. So where is 4? 4 is between 3 and 5, right? Here's 4. Yeah, it should be between 5 and 3. So you could do this formula. So it's going to be f of 5 minus f of 3 all over b minus a. So that's 5 minus 3. So that's going to be negative 2 minus 4 over 5 minus 3. And that is negative 6 over 2, which is negative 3. Okay, so if you estimate it, it's about f prime of 4 as an estimate would be negative 3. Uh, and then it also says find the left Riemann sum. So we're going to draw our boxes. We're going to do, if you look at our table, we go from 2, 3, 5, 8, 13. Darn, none of the widths are off. They're not the same, so we can't take out number. We go from 2 to 3, and then 5, and then 8, 13, right? So if you look at the first box, and if we're doing left side, we got to find, need a different color. Let's use red. So we're going to find this height. So on rectangle 1, the delta x is 1, right? From 2 to 3, the delta x is 1. And then you got to find the height of f of 2 plus, and then if you look at rectangle 2, the delta x is not 1. From 3 to 5 is actually 2. So it's 2. And then find the height of f of 3. Okay. And then rectangle 3, the delta x is what? 5 to 8, 5, 6, 7, 8. That's 3. And then the height is, we're going to do f of 5, I believe. And then plus uh, rectangle 3 is from 5 to 8. Oh, no, no, sorry. We just did that one. We just did rectangle 3. We got to do rectangle 4. So delta x is from 8 to 13. That is a distance of 5. So my delta x is 5. And then we got to find f of 8. Put it all together. F of 2 should be 1. Plus 2 times f of 3 should be 4. Plus 3. And then f of 5 is, I believe it's -2. So where am I getting these values? I'm looking at the chart. So yeah. And then plus 5, and then f of 8 is, what is f of 8? 3. And when you put it all together, you should get 18. Okay, let's do C. So we got to find Riemann sum. We have 2, 3, 5, 8, and 13. So here's rectangle 1, 2, 3, 4, and we're doing right-hand side. So we got to, let's see. So let's look at rectangle 1, this one right here. My delta x is 1. And then we have to find f of 3 because we're doing right-hand side, right? Plus, and then rectangle 2, the distance from 3 to 5 is 2. And we got to find the height of f of 5. Plus, rectangle 3, we got to find what's the distance from 5 and 8? 3. It's going to be 3, and then f of 8. Plus, the distance from 8 to 13 is 9, 5. And then you got to find f of 13. Okay, and put it all together. If you look at, this is 1 times f of 3 is 4, plus 2 times f of 5. I'm just looking at the table. F of 5 is -2, plus 3, and then f of 8 is 3, plus 5, and then f of 13 is 6. And you get 4, -4, 9, and 30. And it spits out 39. Okay, that is the end of Riemann sum. So yeah, it's broken into 3 parts. So I'll stop here.